Welcome back, everybody. Let me ask you, what if the future of manufacturing isn't just about making parts, but it's about understanding the human body well enough to create things that we never thought possible? Today's guest has a background in both biological engineering and kinesiology. It's not easy for me to say, but it's easier for her to do. And they helped develop a university design and fabrication program, making the jump from academic research into industrial additive manufacturing. And what makes her story especially interesting is where she believes all of this could be heading to healthcare, to medicine, applications that could directly impact human lives. So today, we're going to talk about how she found her way into 3D printing, what she learned moving from research into industry, and how studying the human body changes the way that she approaches engineering, and why the next chapter of additive manufacturing may be so much bigger than simply printing parts. But first, this episode of the Manufacturing Alliance podcast is brought to you by Alliance Specialties and Laser Sales, where we are mold makers that don't build molds. We do all the other things that you, the mold maker, doesn't have time to do, doesn't have the resources to do. Everything from polishing, laser welding, laser engraving, hot runner repair, preventative mold maintenance, and anything else that has to do with molds. We also build and sell laser welding and laser engraving equipment here in the United States. It's really important. That way, if something goes wrong, you can talk to the guys that are actually building it, not somebody looking through a binder trying to give you answers. We offer demos, we offer instruction, and we will get you using the equipment the way that you need to use it. If you like the Manufacturing Alliance podcast, please go to YouTube and follow us and subscribe so that you never miss an episode or things that are coming up. Speaking of things coming up, what's coming up? Well, we will be at the National Plastics Conference. It is September 14th through the 17th in Houston. It's where plastics industry goes next, right? Find out all about plastics 2026 conference. Everybody's going to be there. Everybody across the supply chains comes together to learn and help and shape the industry. There's going to be opportunity to do community outreach. Flip does a great job with having an opportunity to go do community cleanup. There are networking opportunities. There's teaching, there's speakers, there's boards, there's everything that you could possibly want. You get to explore sessions focused on business growth and agility and policy and industry impact, engaging technologies, all of those things, workforce development, leadership development, and the future of manufacturing and plastics. It's more than just great content. It's great opportunities for relationships and networking and executives. You can sit in the pool with people that you can't get a meeting with and just hang out and talk. And it's a great place to do those. So if you work in plastics and you want to be part of the industry and where it's going, all you need to do is come out to the National Plastics Conference 2026. If you put in the code Plastics Matters, you will save some money on that registration. So make sure you do that. And right after that, kind of during that, we're also going to be at IMTS. IMTS is in Chicago this year, as it always is. IMTS 2026 is going to be going on. We are going to be there featuring our laser welding and laser engraving equipment. If you'd like a laser welding demo, you'd like a laser engraving demo, come out and see us. It is the International Manufacturing Technology Show. It's going to be at McCormick Place, September 14th through the 19th. It goes all the way to Saturday. So if you have nothing better to do on a Saturday, you can come to McCormick Place and walk around, and everybody will be happy to talk to you because nobody shows up that day. So if you're looking to try and sell your own stuff, come to McCormick Place on that Saturday, the 19th, and everybody will want to talk to you. But other than that, there's 1,800 exhibitors, 90,000 manufacturing professionals, 1.2 million square feet of the exhibition space. And it's going to be everything from CNC machines to automation, lasers, robotics, industrial AI, additive manufacturing, tooling, software, you name it, it's going to be going on. My friend Ryan Weeks, who was on last week, he'll be there also. If you have a problem that you're looking to solve, automate a process, improve productivity, come to IMTS and come see us at booth 135134. And we will be happy to walk through anything and everything that we offer and point you in the right direction to everything else. And as soon as all of that is over, we have our golf outing coming up right after it, September 25th, 2026. If you're not a golfer, great. Most of us are not. We just go out and hack at the ground and have a good time and try and find ways to network, build community, and give to a worthy cause. All of the proceeds to our event go to support iWarriors, where we give iPads to combat wounded veterans to help them with their rehab, to communicate with their loved ones, and to make sure that they know that they're not forgotten, and that they are loved and cared for. So that's coming up September 25th, 2026. We still need golfers and sponsors and all of that stuff. So just go to the website, alliancesls.com, and there's a link to go to golf, and then you can do that. And the last thing I'll say is we are hiring. So if you are a mold maker, or you know a mold maker who is tired of the place that they're working right now, we are looking for qualified veteran mold makers who know what they're doing, love problem solving, love getting involved, love working in a team, and want to make a difference. If that sounds like you or somebody you know, please contact us, reach out. You can comment on this page, wherever you're, or this show, wherever you're watching, LinkedIn, Facebook, YouTube, whatever that might be, or send me an email to T.Demakis at alliancesls.com. And let's have a conversation about how we can bring you into Alliance. It'd be great. I'm going to bring in our guest now. It is Brittany Ratliff. She's got some energy. I think, she said she doesn't like to chat too much, so we'll see how this goes. But I think it's going to be great. Let's bring her in. Brittany, how are you?
Hey, Tony, I'm doing well. How are you?
I'm good. I'm excited to talk with you because additive manufacturing fascinates me, and I don't totally understand it. There's so many acronyms and so many different technologies.
Yes.
We've had people on in different from different companies a number of times, and I love the technology. I think it's so cool, and I think it's a great way to get that next gen involved in manufacturing and get them hungry for what's possible. And so I'm excited that you said yes to coming on and chatting with us today.
Yeah, excited to be here.
So let's talk about you a little bit. How long have you been in actual industry now?
So I've been in the actual industry for a little over 3 years.
Okay.
Graduated from university May 2023, and went into industry immediately after that.
So before going to college, you went to LSU.
Yes, that's correct.
Yeah. So before going to college, when you were in high school,
Mhm.
uh, did you have any thought concept that you wanted to get into manufacturing? Did you understand what it was? What did that look like for you?
Yeah, no, I didn't think I would be in manufacturing at all. I wanted to be a doctor.
Okay.
So we've come very far from that. I started at LSU in a pre medical concentration, like preparing to go to medical school.
Yep.
Until I realized, like, maybe I want to do something that involves a little bit more technology and less people. You've said I'm not very chatty, right? So more technology, less people. So that's when I started looking at engineering.
Okay.
um, so going through engineering, my senior year is when we did our capstone senior design project. And I got really into 3D printing with that. I was the person responsible for the CAD modeling and the 3D printing and prototyping. Um, so having all of that experience translated into me getting my first role in industry after graduating college.
So senior year in college or senior year in high
Mhm.
school?
In college, sorry, not
And
high school.
yeah. So in high school, you were still like doctor, 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 doctor.
Yeah, exactly.
Okay. What made you what had you fascinated with being a doctor?
Um, I've always been interested in like the medical world.
Okay.
I've always been interested in biomechanics and anatomy and stuff like that.
And so just the way that the body functions, the way that it moves, the complexity of it.
Yeah, exactly. The complexity and I guess the mechanics behind it.
Yeah. It it is amazing when you look at it and you think the human body is the greatest machine ever created.
Oh, yeah, it absolutely is. Absolutely.
Uh, it's fascinating to me, and I don't know where you fall on this spectrum, so I'm just going to say it because that's the way I am. I
Mhm.
don't know how anybody thinks that the human body can be an accident.
Okay.
I feel like it points to being created and made with intention and with purpose,
Mhm.
not just, uh, oops, how did this get here? You know what I mean?
Yeah.
Whether you agree with me or not, that's fine. And we can
That's
debate that
fine.
if all you want to, but it just, I
That's
don't understand it when you say, because as an engineer, right, you know
Mhm.
what goes into building something that's complex.
Mhm.
And if
Mhm.
one thing is wrong, it just doesn't work.
Right. Yeah, absolutely.
So, so then you go to college, and
Yes.
throughout college, you realize like medicine is not for me. Was it just the idea
Mhm.
of having to talk to people and like be
Maybe
around people?
not
Because I know a
talk
lot
to
of doctors that
people.
are not very chatty.
Yeah, I guess. I really wanted to be an orthopedic surgeon.
Okay.
Um, and so I still think that that idea, that concept is like fascinating to me, except the part where you actually have to work like on people. You know, like I can go and work on a machine, I can go and work on a 3D printer. I don't want to work on a person, though. You know, that's
Yeah,
completely different. So I think mostly that. And then I didn't wanna go to medical school, you know, I didn't wanna do 4 more years of school,
that's
have more
fair.
student loans, and so engineering just seemed like it was a perfect fit for me.
Yeah. The way that your brain works, the problem solving, I'm sure
Mhm,
you enjoy all of that. I mean, that's all part of the
mhm.
medical field too, is trying to figure out what's
Yeah.
going on with people and what that looks like.
Right, right, and I would still be able to be involved with medical devices and stuff
Mhm.
like that, the biomedical side of things, just not patient specific applications.
Yeah. Which is probably better. I mean, now,
Yeah, I think so.
something goes wrong, you got a bad product. Something goes wrong as a doctor or a surgeon, you got a mess. You got a big problem.
Yeah.
And I wouldn't want to deal with that either. So I get it. So throughout college, you start to make that realization that you don't want to go in the medical field. And then
Mhm.
engineering is the thing that jumped out at you.
Yeah, you know, I've always been pretty good at math.
Mm,
Some people hate math. I've always kind of liked it. And I thought bioengineering would be a really, really good fit since I didn't really want to do the pre medical side of things, going into that technology side of medicine. So I thought bioengineering was a good fit for that.
okay. So then you explore bioengineering, and
Mhm.
what pointed you to get into the additive side of things?
So I really didn't plan on getting into additive. Like I said, my senior year in college doing my capstone project, I was responsible for all the CAD modeling and 3D printing then.
Mhm.
Um, Whenever I was looking for my job after that, after I graduated, I kind of happened to run into a place that was looking for someone to manage their 3D printing.
Okay.
Um, and it just worked out. It wasn't planned that I wanted to launch a career into additive manufacturing.
So you were just open to saying, "Yeah, I can try and figure that out."
Yeah, I can do that. Yeah. Pretty
uh,
much.
and since doing that, has it
Mhm.
fulfilled the expectations that you had? I mean, wanting to
Um,
get into biomedical, right? Has it been able to fill some of that?
I mean, a little bit. So we didn't really do medical device. We did a lot of biotech devices. And usually when you say biotech, people think biomedical. That's not necessarily true. It was a lot of biotech product development. So I've had, experience doing all of that and manufacturing
Sure.
those as well. I've gotten more into the medical device development since I've been at my current job. Um, so we've been doing some implants, some surgical equipment and stuff like that, which is really cool.
Well, tell me about that. Where not names of customers
Mm.
or projects that you're actually doing, because I understand how NDAs work, and I don't want you to get in trouble or your company to get in trouble. But where are you at now, and what do you guys do and focus on?
I'm currently at 3D Gents America. We focus on industrial 3D printing. So stuff like high temperature polymers is our expertise. We are also the original manufacturer of all of our machines. So we sell our machines to customers and we'll also help them with print services and things like that.
I get that, and people go, "That seems like a silly business model. You do the printing and you sell them the machines. Aren't you
Mhm.
just like killing your own customer base?"
Well, not necessarily. I mean, I think the machines are expensive,
Hmm.
right? So some people won't want to buy a machine for 10 parts, you know.
Sure.
So they'll pay us to do the prototyping for them. Or we have some customers who have absolutely gotten their value out of their machine with all of the printing that they've done. So
Yeah, we always look at it when people ask that question. We're like, okay, sure. So somebody starts as a laser welding customer. That's great because they're not ready to buy a machine yet, right? Because they are expensive.
Mhm.
And if you don't sell the equipment, then at some point they're just going to leave you. They're going to go, all right, now I do need to buy this. You've proven that it works. The technology is there. Do you sell it? And you're
Mhm.
like, no. They're like, okay, bye, and they're going to go buy it somewhere else. At least
Yeah.
this way, we can help them. We can make sure that they buy the right equipment. We can take our expertise and our knowledge and transfer that to them, and then we have a customer that stays with us in a different capacity instead of leaving and going to do something else. It works.
Yeah. Yeah. Works here for sure.
Yeah. uh, so through your journey with additive, uh,
Mhm.
what's been what's been the challenge that you found in this technology?
I think probably the most challenging part with additive is um reliability at scale. You know, you can get it's easy to have one print come off of a printer, press print
Sure.
once, right? When you have 100 machines printing the exact same part,
Mm,
they're not going to be identical. I mean, hopefully most of them are, but unfortunately, not all of them will be. And so I think it's consistency
okay.
um, for large scale production.
So what causes that? I mean, if the material is the same, the machines are similar, and I'm a what would cause that to be inconsistent?
Um, well, everything's a little different, you know. One
Okay.
spool of filament's a little bit different from the next. One temperature gets a little bit hotter than the temperature on the next machine. The airflow is different. The fan speed has different RPMs. You know, all these tiny things will pile up, and you'll see very, very small differences.
That makes sense. Because when you're working in tight tolerances, everything matters.
Hmm. Yeah, yeah,
Um, so
absolutely.
how close do you get before you go, no, that one's a failure?
So we have measurement criteria
Okay.
for our print. So if it's with outside a certain tolerance, then we can't use it. Um, we have criteria for print defects. If it's a certain kind of part, like a certain standard,
Hmm.
trying to not go into NDA terms, but um, if it's an important part, basically, then there are more criteria
Okay.
for this part passing quality control.
Sure.
Um,
So tell me about when you were at LSU and you helped
mhm,
design this, to help build the design and fabrication department or
mhm.
program.
Yeah, yeah. So this was my first job straight out of college, and these were the people that looking for someone to oversee 3D printing. So this place is called the AGGRC. It stands for Aquatic Germplasm and Genetic Resources Center. It's really, really, it's a really, really long name.
That's too smart. I wouldn't even apply to work there because I don't know what you said.
Right. Yeah. It's a very, very long name. But they focus on maintaining and preserving the gene pools of aquatic species. So they
Okay.
basically are trying to freeze their genetics, like cryopreserve it. And so a big part of what they're doing is developing technology to preserve this type of stuff. Um, the technology is already existing, um, but it's very expensive
Mm,
for small research labs and stuff like that to get into it. So the HOGRC develops open source um, hardware and technology and stuff like that. And this is where 3D printing comes into it. So most of the technology that is developed there is 3D printed. Um, and because most people have a desktop 3D printer now, you can
yeah.
easily share files like across the globe, and someone on the other side of the world could just print it out and use it.
S- So you would that's what you were working on at in that fabrication program at LSU.
Okay, so that's what the AGGRC does as a whole.
Okay.
There's also they have a 3D printer farm that has around 50 3D printers in it. Throughout the whole facility, there's maybe around 130. They might have more now. Um, so besides sending files across the world for other people to print, they manufacture the devices in house and sell them in kits and packages and stuff like that.
How did you get involved in it? It was your
Involved
job.
in
That
the
was your job out of college.
yes, yeah.
Okay. And so that was the one that was like, yeah, I can try and run these 3D printers.
Yeah, I can try and run this printer farm. It's actually the largest printer farm in Louisiana.
Wow.
Yeah, it's pretty cool.
So I am so naive to this. Are there a lot of aquatic species that are going extinct?
Um, yes, the center mainly focuses on a few species. Have you heard of axolotls?
Yes.
Yes.
They're
So
adorable.
that is like their most popular species
Okay.
right now. And it's everyone's favorite because they're super cute.
Yeah.
Yeah.
Except when they get
Yeah.
really big. Did you know they get pretty big? I thought they were tiny.
I mean, they're like they're like the size of a pen, I guess, full grown. But
Yeah. They
yeah,
they're like most things,
they're
they're
big.
cuter when they're smaller.
Yeah.
And
You
then they get
definitely.
bigger and
I
you
do
see them,
think
you're
they're
like,
cuter whenever they're babies.
God.
Yeah. They get pretty big though, I guess, for a salamander.
Yeah. So that's what
Mhm.
that was trying to do is
Yeah.
preserving the aquatic species and
Mhm.
depending on what that was, the axolotl and
Yeah.
everything else.
Yeah. Yeah.
How has it been going from university, going from college experience
Mhm.
to the actual workforce?
Um, it's been a big shift in what I'm used to. I think the speed in an industrial environment is like maybe 3 times as fast as what I was used to in a university setting. Um, mainly because we're just working with customers and you have to keep up
Yeah.
as fast as possible. So I think that's been the biggest shift for me.
Yeah. There's no opportunity to say, sorry, I slept in. I'll turn it in tomorrow. Right. Like, uh,
That's
we used to have when I went to Western, we had a teacher who she ran her class like it was work. And so
mhm.
if you didn't turn something in, she'd be like, okay, you're fired. Next. Like
Next.
there's no leeway for those things because her job was to prepare students for the actual workforce. Uh,
Mhm.
and I think that's a really big thing that a lot of students are missing is they may develop the ability or the knowledge or the know-how in doing the things, but just that pace of life that you were talking about.
Yeah, yeah. It's definitely a different world.
Yeah. How long? So, what was more aggressive, the AGGRC or 3D Gents where you are now?
More aggressive?
Yeah, in timelines, in making sure
Yeah.
that you have your stuff done when you need to have it done, and customer expectations and everything else.
Yeah, 3D gents is much more aggressive. I've had some very long, very busy days. I mean, I'm juggling multiple projects at once. but I like it. I like the challenge. I like figuring things out. I like having to troubleshoot. So I've been
Yeah,
liking it.
that's good. Have you had a project that you absolutely hated?
Yes. It is one of my first ones too. Um, my boss is gonna hate me if he sees this, but we had to make these little wheel bumpers to go on to the rims of these trucks.
Mhm.
Because they had discontinued this product and this company wanted a replacement, but they couldn't find it since the product was discontinued. So we had to manufacture these little bumpers out of TPU, um, which TPU is like a very flexible thermoplastic for 3D printing. Um, in my experience, it either comes out really, really well or not. Like there's no in
There's no
between.
middle.
There's no middle ground. It'll either come out super pretty or comes out with all these strings and
Yeah.
blobs on the
Like a
outside of it.
disaster.
Yeah, and it just looks awful. Anyways, we were on such this is my first project. We were on such a tight deadline to get a couple hundred of these made, and I printed them 'cause I couldn't figure out the slicer parameters. I could sit there and troubleshoot it, but I didn't have time to figure out, the perfect print settings for this. Um, so we ended up printing all of them with like these not great settings, and I had to clean them with an X-Acto knife after.
So
Yeah,
what did you
so that
learn
was my
from
least
that?
favorite. Um, that's a really good question. I think I probably, since I was brand new on the job, I probably didn't realize the speed of which I needed to do the testing
Mm.
for the project and determining the printing parameters. Um, I think if I had to do it again, I would definitely focus more on these parameters and spent more time doing that because I spent much more time cleaning these little things with an X-Acto knife afterwards.
That's what I was going to ask is if you, like in the moment, you felt pressed for time because it had to get done, had to get done, had to get done.
Mhm.
But if you would have paused for a second and then just like done more testing,
Yes.
it would have taken a little bit longer on the front side, but the back side would have been much easier.
Yeah, absolutely.
Yeah.
I think a lot of 3D printing is like that when you use a different material or something, some parameter that you're not used to.
Yeah.
You could either, take some time and figure out the right settings, or you'll pay the price by having to clean it up later.
What is it about that material that makes it either a dream or a disaster?
I think it has to do with the rigidity of it. It's a very, very flexible material. Um, and so whenever your 3D printer does retractions, it's printing, and then whenever it stops, it actually pulls the filament up so it won't ooze when it's moving to the
Yep.
next portion. It has to do with that retraction because it's so pliable whenever it does retract. Um, it tends to just ooze out more than a typical, like, rigid thermoplastic.
Sure. So when you do that, do you have to cool it faster?
It usually has to deal with the retraction settings. Sometimes you have to increase the retraction speed or retraction distance.
Okay.
It could also deal with the temperature. Your extrusion temperature might need to be turned down. Your flow might need to be turned down. Cooling might need to be turned up. There's so many different parameters
Yeah.
that can go into that.
Too many different variables at one time.
So many variables. Yeah.
And when it's your first project, you're trying to prove yourself, you got a deadline that you have to hit.
Yeah.
People are breathing down your neck. You're like, I just need a couple more days of testing. They're like, nope, don't have it.
Yep. Yep.
So you got tired of an X-Acto knife.
Yes, my eyes were hurting by the end of it too, having to look at these little tiny structures and clean them. I felt like I needed bifocals or something.
You're too young for bifocals. If you have bifocals at this point, you're going to be in trouble. So when you look at all the things that you're doing now with additive, what does that tell you about the future of additive manufacturing? Where do you see it going?
Yeah, well, I think the future of additive manufacturing is absolutely going to grow. You know, people are just starting to get desktop printers into their homes widespread. Um, I think companies aren't yet realizing the potential gains that they can have from having a 3D printer.
Yep.
And I think it's just starting to launch itself in the US. The European market has been all over it for years. They've been much more advanced in additive manufacturing than we have for a long time. But I think the US is finally catching up.
What do you attribute that to? That the European market has been ahead of the game.
That's a really good question. A lot of the machines are European machines,
Mm,
until recently, until China has started developing a lot of machines. Um, I think Europe was probably just the original manufacturer of the machines, starting maybe like 10 years ago, 15 years ago. Um, so that probably helped them adopt it a lot faster than we did.
okay, that makes sense. Um, do you feel like a lot of the U.S. companies, now that they are getting into it, are they moving fast with it? Are they um, taking too many baby steps? How do they get to that next level? Is it just practice and experience?
Yeah, I do think the US is still moving a little slow, but it is baby steps. Once you get your first like big 3D printer, you know, not little desktop thing, but whenever you get like your real 3D printer, I think a lot of people do take baby steps trying to figure out how to use it because they don't want to break it, right? They're kind of afraid of it a
Yeah.
little bit. Um, we do have some customers that are not afraid of it at all. You know, they're loading up a full build volume and just sending it, and then they have problems. Um, but yeah, most people are a little bit hesitant to just launch into additive.
Yeah. It makes sense because if you don't know what you're doing, it is a totally different animal. Um,
Mm.
we know people that they do additive for the plastic injection space, whether that's
Mhm.
3D printing, mold inserts or full molds or whatever that looks like. And there are differences for engineering and developing for 3D versus um, plastic injection or extrusion or whatever that looks like.
Mhm. Mhm.
Have you gotten to design for both or just for additive?
Um, I've done a little bit of design for CNC machining as well as laser cutting and water jet cutting. Um, additive has been like my like predominant skill set.
Yeah.
Um, but yes, I have done a little bit of design for like traditional manufacturing. Yeah.
What do you prefer?
3D printing,
Why?
100%.
Why?
Um, that's a good question. I feel like it's so much easier
Okay.
than CNC machining and generating tool paths and all this stuff, you know?
What makes
Um,
it easier? Do you not have to do tool paths with additive?
I mean, so you do,
Okay.
yes. You do. You have to generate it in this a program called the slicer.
Okay.
Um, but you you put your printing parameters into the slicer and it generates the toolpath for you.
Okay.
Um, whereas I've generated toolpaths for CNC machining and Fusion before, and it takes forever. So in a slicer, you just hit a button, slice, and then it does everything for you. Um,
So
yeah, I
maybe
think 3D printing
maybe
is so much
the
easier.
the software that you used before was just a little bit more antiquated than the software for the additive.
Maybe so. I have used like a hobbyist CNC machine, and that
Sure.
was much easier. It was almost like bamboo printers have their
Okay.
Maker World site where you just send it straight to the printer. It was
Yep.
sort of like that, where you just send a design straight to the CNC machine rather than having to generate toolpaths.
I would think that additive would be more satisfying because it's so much more immediate.
Mhm.
When you're
I
building
guess
a
so.
plastic injection tool, there's so many other things that have to happen before you get that product. Uh,
Mhm.
when you're working with additive, you basically have it. Like it's done, and now you have the thing,
Yeah, yeah. Like
which I
every
think is
morning I
great.
get here, yeah. Yeah, every morning I get here, start a bunch of prints, get them off before the day ends, then start overnight prints and restart the cycle every day.
Yeah.
Um,
All right. So you told me your least favorite project, the one that
mhm,
gave you the most headache. What is
mhm.
your favorite thing that you have printed and engineered?
I think the most interesting thing that we've printed are spine implants.
Okay.
They're they're inner body fusion cages. So whenever someone gets like a spinal fusion surgery, um, this is what is inserted between the vertebrae. Not every surgery is like a little bit different. Some
Sure.
people don't have anything between their vertebrae, but um, yeah, I was able to design a fusion cage, and then we printed a few prototypes out. That was really cool, I
Yeah.
think.
And that has to be really satisfying to know that you are really making a difference in people's lives. Uh,
Mhm.
Not just like you're not just making a pen, right? A lot of
Yeah.
times.
Yeah.
Was that a goal for you, to be able to have impact in people's lives?
Yeah, yeah, absolutely. I think if you make a car part that's cool, it's gonna go in a car.
Yeah.
Does anyone care? Maybe not. Um, but if you're making an implant for someone that is undergoing spinal fusion surgery, that's gonna make a big difference in their life.
Yeah, they're going to go from being paralyzed potentially to functioning as a
Mhm.
regular human being, not regular
Yeah.
human being, you know what I mean? Having the use of all their appendages. And
Mhm.
um, I remember there is a guy that works for us, and we were doing a mold repair for a medical part, and his wife had had a stroke, and so they went to the doctor, and they were sitting there, and she was in the chair, and he was like looking around the room because what else is he going to do? And he looked down, and he actually saw the parts for the mold that he was repairing in the
Mhm.
doctor's office, and it occurred to him how much of a difference he was actually making, that these things that he was doing, by repairing the mold and doing all this, it was actually life-saving technology and life-saving repairs, and it put a whole new spin on his thought process to what his job was.
Mhm. Yeah. I would love to be able to see that side of my job, the patient side of it, see the effects of it, the outcome of it.
Yeah, that it's just so cool when you can
Mhm.
break those things down. um
Yeah.
we talked about it a little bit in the beginning with my opinions. Uh,
Mm.
how do you feel that studying the human body helped you, like, changed your approach to engineering?
I really like this question because I think it brings together kinesiology. So I understand biomechanics, I have this understanding of anatomy, I see how the human body works. And
Mhm.
then with engineering, I have this problem solving side, this troubleshooting side where I like to figure things out. Um, and I'm trying to find this perfect intersection of kinesiology, engineering, and additive manufacturing. Um, and so I think I was able to use a lot of that when designing these inner body fusion cages, and taking into account anatomy and biomechanics and things like that um, when completing this project.
So that's a passion of yours. That's a direction that
Yeah.
you want to go in, is merging those ideas together.
Hmm. Yes. Yeah. Absolutely.
Do you feel like that's where the technology is going to take it?
I really hope so one day that I hope the medical community realizes the potential gains that they could have from adopting additive manufacturing. Um, I think every hospital should have a 3D printer. I don't know why they don't. It would make their life so much easier. They don't even realize what they're missing out on right now. Um, but orthopedic implants and prosthetics and things like that, that's getting a lot of traction within the medical additive community, especially casts and things like
Yeah.
that. Have you seen these like customizable casts that are,
No.
oh, they're so cool. It's they have been 3D printing casts, usually with resin
Hmm.
printing, but they're breathable, so you can actually see people's skin underneath it. You can get it wet, and it's not like the typical cast that has the plaster that hardens and you can't see your skin for 6 weeks or whatever.
And then you get stuff
Um,
like trapped in there because you try and scratch and
yeah, exactly. You can't get it wet.
yeah.
Yeah. So, um, yeah, stuff like that, splints, casts have been really, really popular recently. Additive is also great for it because it's customizable. You can easily customize it per patient. Um, so that's another benefit of additive in that community.
Based on that, why do you think it's not taking off as fast as it should? Right, to your point,
Mhm.
uh, hospitals have a lot of money. Why
I do.
wouldn't they
Yeah.
invest in this technology? Is there a downside to it, or is it just it's the way we've always done it, so it's the way we're going to keep doing it?
I think it has to do a little bit with this is the way we've always done it. Um, I don't think they realize the potential benefit they could have from it.
Hmm.
But they probably also don't want to invest their time in it if they don't realize the benefit that they could get from having that. It's sort of probably like this fear of the unknown, you know?
Yeah. Well, and I mean that's a real thing. Is people don't necessarily want to invest in things that they don't understand, um, which makes sense. Some people may look at it and say, "This is this is not going to last." Right? We're going
Mhm.
to go through this too quickly. It's too expensive. We can do the cast the old way. Like nobody cares. Nobody's gonna pitch a fit about that. But if I had the choice of having the breathable, customized cast versus the old plaster, nasty one that smells, I'm
Mhm.
gonna take the new one.
Yeah, I think 99% of people would.
And I think it's just the tip of the iceberg when you look at what that could be.
Mhm. Absolutely. Absolutely.
So, this is a question I'm going to start asking everybody, and you get to be the
Okay.
first one.
Oh, no.
What is the one thing that manufacturing needs to change?
I think that's a really, really good question. I think, um, probably speed.
Mm,
I think manufacturing tends to be very, very slow. Um, and people might not understand why it's slow. There's a lot of testing and things that have to go before production, especially with additive. You know, you can't just get an STL file and start mass producing it. You know, you have to select materials, adapt geometries so they can be printed with additive, um, develop process parameters and stuff like that. So I think there's a lot of um, like setting up and initial testing you have to do before production. But I think as a whole, the manufacturing industry could probably move faster. From a customer standpoint, everything seems to move very, very slow.
mm.
So
From a customer standpoint,
I think so. Yeah.
where the customer, like the end customer, has to wait on results.
Yeah. Yeah. Like they're waiting on production, waiting on their parts, stuff like that.
Okay, uh, you're a female. Uh, that's I
Yeah.
yeah, you would agree.
You're
Uh,
not wrong.
yeah.
Yes.
Okay. Cool. Yeah. Whew. Can never be too sure. How a lot of times women in the manufacturing space or in the
Mhm.
workspace, in the past, I don't know now. That's why I'm asking. Find it to be challenging to be a woman in the manufacturing space, getting into it or being seen as an equal, or different issues along those lines. Have you experienced any of that?
No, I don't think so. I haven't experienced anything like that. It's not something that I think about ever, honestly. I think this is the first time I've thought about it.
Hmm.
Um,
Great.
I mean, yeah, I don't have any problems with it. I think the only thing that I've asked my male coworkers to help me with is like stuff with like grip strength. Like I couldn't open something.
Sure.
Now that I say it
Sure.
out loud, but like just grip strength. I mean, that's literally it.
Yeah. No, and I think that speaks to the industry and people growing as human beings and getting
Mhm.
over their stuff. You know what I mean?
Yeah,
Uh,
yeah.
because if you talk to uh, people from an older generation, they'll talk about how they had to overcome these barriers, and teachers would look at them and say, "You should not be in engineering. You shouldn't be in manufacturing. You should be in this category." Uh,
Mhm.
are you seeing, or did you see when you were in college or in high school, even um, more women uh, getting into the space and being interested in engineering and design and manufacturing?
Yeah, yeah, absolutely. At AGGRC, they have a very large team of that makes up their additive manufacturing sector, and there's a lot of women on it. There's a lot of engineers, like women engineers, getting their degree. There's a lot of technicians, so student workers that are still um, at the university, still working towards their degree. Um, but I would not say that men are dominating the AM industry.
It's great, and they've all treated you well.
Yeah.
That's great. Makes me happy. It makes me happy to hear. Have you gone to any specific like women's in manufacturing events or anything like that?
No, I haven't.
Okay. From what I understand, they're great. I've never been to. Well, I think I've been to one.
Okay.
I didn't know I could go because I thought,
Okay.
women
Yeah.
in manufacturing. Uh,
Yeah.
but what I learned was sometimes the women are upset that men don't come because then they feel like they don't have advocates. And I was really, really
Okay.
confused because I thought then I was like, great. I mean, I lose either way. That's not fair.
Okay.
Just tell me if I should go or I shouldn't go, and
Mhm.
I'll do that
Mhm.
thing.
Yeah, I
Uh,
haven't really like looked into any groups like that. I'm not opposed to it. I just haven't
yeah.
joined any.
How long did you do the pageant thing for?
So I did that for 3 years in college.
Okay.
Um, it was eh, I did it 2019, 2020, 2021.
Okay.
Um, 2020 got canceled because of COVID.
Yeah.
So I was still, rehearsing and all this stuff, but I just wasn't able to do the pageant. Um,
I'm surprised
but
they
yeah,
did
20
2021.
yes, I wanna say it was, like, fully online. It was
Okay.
so long ago. I think it was fully online, like, there was no audience.
Okay.
Everyone was there, like, all the contestants were there in
Yeah.
person. We were all having to wear masks backstage and stuff,
And
keep
then
the
hold your breath
6
when you go on
yeah.
stage.
It's a 6-foot rule. Yeah, there was no audience or anything like that, but the judges were in person. It was an interesting experience doing
Yeah.
the first one normal pageant and then going to one that was, like a COVID pageant.
Did you enjoy
Yeah.
doing that?
I did, I really did enjoy it, yeah. It's something that I wanted to do for a long time, and I never really had a great reason why
Mm.
I wanted to do it. I think I'm just competitive and I just, like, wanted to win, and that was just, like, the only reason I wanted to do
Did you
it.
win?
I did not.
Okay.
I still, like I would like to do another one. I just have to find the time to do it.
Yeah.
Yeah.
When you say you're competitive, where else does that show up?
Where does it show up?
Yeah.
I don't know. I'm very into like health and fitness and stuff like that. I always
Okay.
have been. I've always been in the sports. I played a bunch of sports growing up throughout high
What were your
school.
sports?
Um, I did quite a few. So I did softball, gymnastics, swimming, and water polo.
Okay.
Yeah.
What was the hardest?
Water polo was definitely the hardest.
Yeah. I
Yeah.
would imagine so.
Yeah.
Water polo
Yes.
fascinates me. That's too much treading water.
Yeah. It was my favorite out of the four.
Okay.
Yeah.
Because it took all the other skills that you had learned in the past.
I guess so. That's a good point. I haven't really thought about it like that, but yeah, I think so. I think it was just also the most competitive one, the most high stakes one that
Yeah.
I was just so passionate about it. I just wanted to win.
Do you come from a competitive family?
Um, maybe. Yeah, I don't really think so. I mean, I never really like competed with my sister that much or anything. I think it's just me.
Okay. Where does that drive come from? Like, you just like, I need to win. Like, I'm playing shoots and ladders and I need to win. Like, is that
I don't know. I don't know where it comes from. I don't know what makes me want to be competitive. I just
is it that you love to win or that you hate to lose?
I don't hate to lose. I think I just love to win.
Okay.
I like to put effort into something and like see the results of my
Mhm.
effort.
Wouldn't it be amazing if everybody felt that way?
Yeah, yeah,
I mean, I think the world would be a much better and productive place if everybody had that kind of um, passion to see results and be results driven.
yeah, yeah. I know a lot of people are maybe process oriented, but I'm definitely a results oriented person.
Yeah. Did you ever see the movie Little Miss Sunshine?
I don't think so.
Oh man, as a pageant person, you have to watch that movie.
Okay, okay. I'll take note of that.
Yeah. And then you have to let me know if you enjoyed it or not. It's a little
Okay,
bit
I
it's a
definitely
little bit
will.
dark. It's a little bit dark humor,
Oh,
but
okay,
uh it's good. I don't want to spoil anything for you, but it's good. It's older. It's an older movie.
okay. Yeah.
Uh we just watched it over the weekend again with my wife and two kids. My son
Hmm.
is he's going to be a junior at Illinois Wesleyan, and my daughter is a senior in high school, and they both liked it. So
Okay.
it's
Yeah. I'll
not just
definitely
an
have to
old
look it
person
up.
movie.
Okay. I'll definitely look it up.
Okay. You want to play 5 questions?
I'm not sure what this game is, but sure.
What could go wrong? What could go wrong? All right. Here we go. First question. First question with Brittany. If you could make one rule that everyone in the world had to follow, what would that rule be?
That's a really good question. Maybe go to the gym once a week.
Hmm.
Yeah.
You think
Yeah.
once a week is enough? Like, if somebody goes once a week, do they get that? Um, do they get that desire to want to go back? I feel like once a week is
I
enough to
mean,
like make you sore every time you go.
yeah, yeah, absolutely. I think some people want to go more. I mean, I'm one of the people that want to go multiple times a week. I feel so much better after I go. Um, I think once a week is enough for someone to
Okay.
keep them motivated and keep wanting to go.
Yeah.
I mean, it's so good for your health long term. I think it's really important.
I'm like you. I'm 7 days a week. I have to do it. It helps my mental clarity, helps me focus, helps me be prepared for the day, and it helps my body dysmorphia. If I'm being honest, we're all crazy in some regard. I know it.
A little
It's
bit.
fine. I
Yeah.
know. I know what I got going on between the undiagnosed ADD and it's we're all a mess.
Yeah.
Question 2: what is one thing that you're superstitious about?
Superstitious.
Or like an OCD thing that you have? My brother says
Mm,
for me it's not so much superstitious, it's like an OCD. Like when I go to the bathroom and I wash my hands, I always use 3 paper towels. I hate hand dryers. They're the worst. But
I don't like hand dryers either. Um, I don't that's an interesting question. I think I'm very organized. I'm very clean. Like all of my stuff has to be in a certain spot. I sound really OCD right now. Um, but I think it's just organizational side of me has to keep things a certain way or my brain just doesn't function as efficiently as it could.
it's probably what makes you a good engineer. Having your spaces cleaned, being organized, knowing what you want,
Yeah.
everything has a place.
Yeah.
That's that's
It's
why I'm
definitely
not
the engineer side of me.
yeah, that's why I'm not an engineer. Number 3, if you swapped genders for the day, how would you spend your time?
Um, I would probably go to the gym and lift as much weight as I possibly could. See how strong I was. Yeah, I don't know. I think that's really the only thing that I, I can't do as a female is lift as much as, a man.
Okay. All right. It's fair. Number 4, if animals could talk, what would be the rudest and why?
Like, which animal would be the rudest one?
If they could talk.
Um, no, I don't know. The first thought that popped in my head was my boyfriend's Maltese. He would probably tell us how neglected he is.
Is he neglected?
No, he's not neglected at all. He's just spoiled.
That happens with children too.
Yeah.
If you spoil them too much, then when you don't give them any attention, they're awful.
Yeah.
So there's that. All right, last one. How many kindergarten kids could you take in a fight before you were outnumbered?
Realistically,
Yeah, yeah.
well, my niece is in first grade, so I can kind of imagine, not imagine, kind of base my guess off of that, I guess. I know how tall she is.
Hmm.
Probably like 3,
Okay,
maybe.
okay.
I think I'm pretty tough.
The problem is when
I
they
don't
get on
know.
your ankles, when they grab your legs.
And they just
Uh,
wrap around you.
yeah, yeah, yeah. They're like a python. Not that I fight a lot of kindergarten kids. Sounds bad,
Yeah.
like I have experience, but
Like you've
uh,
done
no, it's good. Uh, I want to be cognizant of your time. Anything else that you would like people to know about you and what's going on and the technologies and your passions for them?
I think that's the majority of it. I'm just really excited for the future of additive manufacturing and healthcare and hope I can get to do a lot more of that in my future.
Okay, let me ask you this last question. What can we do to get that next generation of students and workers interested in manufacturing? How do we keep their interest and get them into the space?
Yeah, well, I think additive is really, really growing among like school age kids and college kids now. Um, I think a really, really easy way to introducing new people to additive is by putting like a desktop printer in a classroom in a maker space. In a maker space, you could do CNC, laser cutting, all
Hmm.
this different stuff. Libraries are a great way to do it, and outreach.
I love that. And I think that's a thing that people are doing. I think kids are becoming more interested in it. You see kids with,
Oh
their
yeah.
3D printed fidget spinners and lizards and all kinds of fun things. So I think you're absolutely right. Um, now, I end every show with a prayer. Do you have any prayer requests?
No, go for
Good.
it.
I'm glad life is good.
Life is good.
All right. I'm going to pray and then I'll let you go, and then
Okay.
it'll be great. Heavenly Father, thank you for today. Thank you for this time to talk with Brittany. Thank you for this experience. Thank you for the passion that you've given her to understand the human body and take that tech knowledge and bring it to technology to make people's lives better. We just pray that you would be with her and with the people that she is working with and working for, and that the technology that she continues to work with would change people's lives forever. Thank you for this time. And we pray all this in Jesus' name. Amen.
Amen.
Brittany, thank you for being my new online friend
Awesome.
and for spending an hour with us and sharing your passion for what you're doing and just being involved in the space and making it fun. So I appreciate it.
Cool. Awesome. Thank you so much for having me, Tony.
Of course, we'll talk to you soon.
All right. Talk soon.
See you. Bye.
Bye.
All right, that was Brittany Ratliff. I love these additive conversations, and I love the conversations, having the conversations with the younger workforce, because let's face it, this is what we need. We need an infusion of youth and of new passions and new ideas and new energies to continue to make manufacturing in the U.S. amazing and make it great. It's not going to go away. Manufacturing in the US is not going to go away. It can't go away. We have too many innovative people. We have too many passionate people. We have too many people that like to solve problems and make things happen. These are the jobs of the future, and these are the people that are making it happen. So it's awesome to hear that kind of passion and knowledge and willingness to do the next thing, whether that's in the medical space or in the automotive space. All of it is going to improve based on us getting more involved and doing all these things together. So thank you, Brittany, for joining us. I just want to remind everybody once again, come see us at IMTS. Come out to the National Plastics Conference. Come out to the golf outing. Let us know if you want to try a laser welding, laser engraving machine. We will bring it to you, and we will do the demo for you and with you. On behalf of myself, Brittany, and Alliance, thank you for watching. Thank you for listening. Take care, and God bless.